Alright, then we have the last part of this chapter of the section of forces, that is the circular motion. So whenever an object moves in a circular path, then the object is said to be moving in circular motion. Objects are moving in a circular path due to constant force acting towards the center of that circle. Acting towards center of the circle. Which circle? The circular path in which the object is moving. So the force that acts during the circular motion is called centripetal force, and the direction of that force once again is towards the center of the circle. Example is you have a NASCAR or race car moving in a circular path. What is the direction of resultant force? The direction of resultant force is perpendicular to the direction of motion at that point, which is this one, and towards the center of the circle, or you can say towards the center of the circle. And the direction of motion and the direction of resultant force would always be perpendicular to each other. So centripetal force is the resultant force that causes an object to move in a circular path. Centripetal force is a characteristic name given to any force. Now the thing is, this is something that we study in details in A levels. So over there we actually find out that centripetal force itself is not a force. It's not that centripetal force is a special kind of force just like magnetic force or electrostatic force. No. Centripetal force can be any force, and that force can be given the name centripetal force if that force is responsible for making an object move in a circular path. If it is a magnetic force that is making an object, let's say electron, moving in a circular path, that magnetic force would be the centripetal force. If it is a gravitational force, then that gravitational force can also be called as centripetal force. So is a name given to any force that makes an object move in a circle. The same thing. So it can be any force. For example, when you are rotating a stone which is attached to a spring, in that case, the force that is keeping the stone moving a circular path is the tension in the string. All right, let's say here's the person who is trying to make a stone move in a circular path. And let's say here you have the rope and this stone is moving in a circular path. Let's connect it to the hand. Yeah. And this one moving in a, let's say, circular path. So in that case, the force would be there, that is the tension in the string, and it would be towards the center of that circle once again. All the planets rotating or revolving around their star. For example, our planet, the Earth, when it is revolving around our star, which is the sun, Then the force that keeps the planet rotate in the circular path around the star is gravitational force. So where does the centripetal force comes from in that case? From the gravitational force. Electrons revolving around the nucleus, in that case it is electrostatic force. Electrostatic force. Water in a rotating bucket, in that case it is reaction force. The centripetal force can be increased by these things. First of all, if the mass of an object is increased, or the speed of an object increases, or if the radius of the circle decreases. The planets orbiting around the sun due to constant centripetal force acting towards the sun. And where does that centripetal force comes from? In that case, it comes from the gravitational force between the planet and the sun. The electrons are orbiting around the nucleus due to constant centripetal force, all right, acting towards the nucleus of an atom. And in this case, the centripetal force comes from the electrostatic force. So you can write electrostatic force as well. So here we have the question, sample question. Particle P moves in a horizontal circle about O. P moves at a constant speed. So the speed is not being changed, but the direction of the object, direction of the motion is being changed at every point. For example, at P, the direction is upward. When an object reaches at this point, the direction would be over here. At this point, the direction would be over here. So direction changes at every point. Speed is constant, but velocity would not be constant. So velocity changes because the direction changes. So always keep in your mind, always in a circular motion, even if the speed is constant, the velocity can never be constant. Because velocity has to include direction as well. And if the direction changes, the velocity would also change. Anyway, which statement is true? A force of constant size acts on P in the direction of motion. No. That centripetal force has a constant magnitude. That's true, but it is not in the direction of motion. A force of constant size acts on P towards O. Okay, let's skip it for a while. The force P varies in size. No, the force, centripetal force, is a constant force. If the speed is constant, the amount of force would be constant. There is no resultant force acting on the P. No, there is a force whenever an object moves in a circular path. There is a force, and we call that centripetal force. So B is the right answer. Like I said, the direction of that centripetal force is always towards the center of the circle. So this is the direction of your centripetal force. F sub C represents force centripetal or centripetal force. A satellite is orbiting the Earth. What is the direction of force on the satellite causing this circular motion? Away from the center of Earth? No, it's not away. In the direction of motion? It's never in the direction of motion. Rather, it is perpendicular to the direction of motion. not in the direction of motion, rather perpendicular to the direction of motion. In the opposite direction, no, not opposite. Like I said, perpendicular. So perpendicular doesn't mean opposite. Towards the center of the earth, yes. So if you have the satellite, let's say here you have a satellite, and here you have the earth, and the satellite is going around the earth, the direction of the resultant force acting on the satellite would be towards the center of the circle, which is towards the center of the earth. No matter at what point the satellite is, the direction would always be towards the center of the earth. Then you have the next one. The diagram shows a cyclist leaning over in order to cycle around a corner. Which force is necessary to maintain the motion around the corner? So in this case, the force necessary for the object to keep moving in a circular path would be centripetal force. And the direction of centripetal force is towards the center of the circle. Now we have to guess here what direction would represent the center of the circle. And it has to be guessed from the way the cyclist is leaning over. And if this cyclist is leaning over like on this side, so the direction of the circular motion would be this. I mean, he's going to move in this path. We can notice it from the way he is leaning over the path. So for this one, A would be the right answer, because A would then be towards the center of this circular path.